Good afternoon and welcome everyone to our final session in the August Bite-Sized Corrosion series. It's worthwhile to draw back to what we've been discussing, and that is water and the effect of contamination of water. We've looked at the impact of acid mine drainage, some of the considerations to be taken into account with infrastructure within those contaminated areas. We've looked at the corrosive effects of water that is very pure when we spoke with Lesotho Highlands, just on how those pure waters can be really quite troublesome in terms of corroding our infrastructure. And it's been really encouraging to see that companies, water utilities, have taken cognizance of the information that's come through what we know in the industry about corrosion, what we've learned about acid mine drainage, and have been implementing it to ensure that suitable mitigation measures are in place. Today, we're going to explore some of the other considerations that we need to take into account as water utilities to mitigate some of the impacts of water contamination. And I'm very privileged today to be joined by Nthabiseng Sibisi. She's an engineer at Rand Water, and she's going to be helping us to understand some of the impacts that they need to consider. So Nthabiseng, thank you so much for joining us today.
Thanks for the invitation, Vanessa.
It's a pleasure. As we kick off
Yes.
today, the challenge that we need to consider is that while water is your key product to us as consumers, managing its impact on your infrastructure is also critical.
Yes, that's true. Basically, just to introduce myself, I'm Nthabiseng Sibisi, and I've been with Rand Water for the last 8 years, both as a consultant, a metallurgist, then lately for the last 5 years as a fabrication plant manager under, the engineering division at Rand Water. So just to give you a bit of background about Rand Water, basically Rand Water has been operating for about 121 years. It's the largest bulk water utility in Africa, and I hope everyone is aware, and then providing bulk potable water to more than 11 million people, basically Gauteng, Mpumalanga, parts of Free State, as well as Northwest. Our biggest infrastructure at Rand Water is mainly our pipelines. And our network for pipelines is about 3,800 kilometers. That's how far it stretches to. And then within the pipeline, obviously, we have pipeline accessories, our valves, our pumps, motors, as well as some civil infrastructure. Then my role at Rand Water, as Vanessa has mentioned, I am an engineer, a metallurgical engineer to be exact. My role was mainly on fabrication for the last couple of years, but it was not limited to manufacturing of pipes and selection of coatings. So with pipeline contracts, I am also a part of the team with selection of coatings. For the assets team, I'm there. For the specification, I form a part of that. And basically, selection of steel. What is designing for? What's the thickness? What pressure? Is that steel sufficient? Then I have a look. I've had the pleasure to run those contracts for pipeline manufacturing as well as for the procurement of steel.
That's fantastic, Nthabiseng. It's lovely that you've got such a well-rounded view, and that's really helpful for us this afternoon in our conversation. So thank you. Talking about your nearly 4,000 kilometer pipeline network, that your challenge actually as a water utility is that you are dealing with so many waters, because some of your pipes are carrying raw water or unprocessed water, some are carrying treated or potable water. And of course, they're also encountering water just in the environment by the very fact of being buried in the soil. So I think there's this huge impact of water upon you.
Yes, as you did say, we have various different types of water. And you can imagine the changes that the business has endured because of this. Changes in technology, new proposals coming into the space. But let's start with potable water. Our infrastructure mainly is pipelines, and they are designed for about a lifespan of 65 years. And within the 65 years, the pipe is actually being monitored. The condition of the pipe is being checked periodically. So you're able to tell that these pipelines are struggling more, these ones are still in a good condition, and then you draw your conclusions from there and how you're going to deal with the pipeline. So with our 121 years of operation, Rand Water has evolved with respect to the primary material used for our pipelines. In the past, they were using mostly pre-stressed concrete pipes. Then steel pipes started getting into the space, steel pipes with riveted joints, steel pipes with lead cock joints. And then now I come into the picture when everything is being welded. As you know, we're getting rid of lead cock joints, our riveted joints, and replacing some of the PCP structures. And then similarly to the pipe wall, there have been changes with respect to external coating and internal lining over the years, with the selection based on the environment, availability, material history, longevity. So, and let's just say track record plays an important role in the selection of these coatings and linings. And as we all know, basically coatings must provide primary defense to the main material, which is our steel, depending on soil conditions and on stray currents. Unfortunately, our pipes are very long. So we have pipes 10 kilometers long, 20, 30 kilometers long, and the environment throughout the pipeline does not remain the same. And you have to choose one coating, one lining, and one pipe wall. So that's actually a disadvantage to the long pipelines, to this large network, and sticking to the same material. So that's a bit of a challenge. And then Rand Water continues to augment with new pipelines. What I mean by this is that we have augmentation projects whereby the demand is determined, and based on the demand, then you have to change, and statistics and population, and Gauteng is growing every day. So based on this demand, we have an increased demand to increase our diameter. So the older pipelines would be along the 600 millimeter diameter, 6 millimeter thickness. And now, we go from very small pipelines all the way to our biggest is about 3.5 meter diameter. So Rand Water then continues to augment with new pipelines based on demand, as well as refurbish, because now we're at 121 years. So the 65 years has come and gone many times over. So now we have to look at the age of the pipe, the environment that it's exposed to, and have a look at whether we need to augment. Are we still within the same demand parameters, or is there now a need to refurbish the existing pipeline? And we're keeping it same diameter, same thickness, and where we see that the thickness has deteriorated or some of the pipe is gone, then we talk about a replacement of that particular section. In that case, because the pipe has not been augmented, we refer to it as being refurbished based on, the type of aging that has occurred.
That's quite interesting to think about the refurbishment, replacement, and augmentation. And I understand that, as you've been mentioning, the pipelines that you're dealing with, if you're repairing an old pipeline, for example, and you're putting in a new segment, that also brings some interesting corrosion challenges, because the steels today are different from the steels that perhaps that pipe was originally manufactured in. And as a corrosion person, I'm going to say, when you have two different materials, we don't want to have galvanic corrosion. But also, as you rightly said, there's been a change in the coatings. And so what you're putting on the internal of the pipe and probably the external of the pipe also need to be considered, and the impact of this new piece of pipe in the extensive pipeline that also needs to be considered.
Yeah. And also remember, Vanessa, that with the refurbishment especially, you have some corrosion that has played a part in the decision to refurbish or replace a section of the pipe. So with that, you basically changing the conditions of the soil as well, because that pipe has leaked in that area. It has created a new stream in that area,
Yes.
if I can call it that. Remember, we have the streams that are natural, then we have the ones that are man-made. So that has created corrosive soils now, low soil resistivity. So we also have a look at that. And then with augmentation or refurbishment projects that Rand Water continuously embarks on, we include the pipeline protection portion as part of every contract, which covers cathodic protection of pipe as well as protection of assets in cases of vandalism, because that's the other
That's a big
aspect
problem.
that we're dealing with as a country. Vandalism of TRUs, vandalism, they need water, they just pierce the pipe
Punch a
and
hole
take
in
the
the pipe,
water.
yes.
Yes, so that happens a lot. So potable water pipelines are limited to being internally lined with epoxies or cement mortar at the moment. And then our external coatings, our spec is basically still limited to rigid polyurethane, bitumen, whether it's our bitumen, polymer modified bitumen, any variants of the bitumen, and then 3-LPE and its variants as well. I know that there's Sintercoat products and the likes. So that's what we have for potable water lines. On the other hand, now we have infrastructure that's carrying raw water. We have infrastructure that's involved in coagulation and flocculation processes. We're adding chemicals. We're increasing and decreasing the pH. We're removing heavy metals. We're basically adding and adding to purify this water. And then we have our sedimentation and sludge disposal. And then we have filtration, chlorination of the water before the water can actually be discharged to the various points where it should go. And then the challenge now here is that we don't have coatings and linings that match the environment of service. One might look at the 3,800 kilometers and say, okay, let's focus, let our focus be on our epoxies, cement mortar, as well as our coatings that we've already have on our spec. That's good enough. But it's not, because then in those areas where we have processes for purification of water, we are running everything till the end. I've never seen bolts not looking like bolts anymore. So the coating completely falls off, and you can imagine what's happening to the lining. And in those kind of environments, we are unable to see, we are unable to stop and replace.
Yes. You only stop when there's a crisis.
There's a crisis. So Rand Water basically still needs that coating and lining regime. So we're still at that point where we need to explore that, because our pumping stations, our purifications, our tanks are also valuable infrastructure. So we need to protect them as well.
And in fact, with a lot of that equipment, it's difficult to decommission it because they're being run and there is no, if I can say, backup. There's no second route that you can take one offline for an inspection. And I hadn't actually given the thought of corrosion of that plant and infrastructure. That's actually quite critical. And yet, as you rightly say, it's something that we don't really consider. And when we do consider a pump, for example, there are always so many different materials that are used in the construction of a pump. And yet, as corrosion people or people who've been exposed to some form of corrosion, we all know different materials. You're setting up the possibility of galvanic corrosion. And yet, in these pumps, that's very often they are constructed of different materials. So that is something that we need to perhaps lend some thought to. Maybe there's a university lecturer on the call who can say that's a topic for research.
It needs to
because
be explored.
I think we need to give some attention to these areas where we can't easily follow up and where we don't have necessarily the case histories. As you rightly say, in the pipeline sector, we've got lots of case histories of internal linings that do and don't work and external coatings that do and don't work. and we've got quite a rich repository of information.
So that area is actually a gap for Rand Water, and including all the mechanical assets that we have that are actually running with the various pipelines, with the various tanks. That coating lining testing regime needs to happen so that those assets are protected as well.
Yes. Now, I know that in the implementation of your pipeline installation contracts, some of the challenges that you're facing with the new infrastructure is that you're facing it because you're required to use an inexperienced contractor. And we can debate that, and there's definitely merit in our country of low skill where we see the merit of that.
Yes,
But
yes.
do you also find with the major plant infrastructure, do you find inexperienced contractors can also exacerbate the problems there as well?
I think with the major works, you find that, let's just give a pipeline M11, for example. Let's say the pipeline is over 200 million. Then the CIDB grading that's required for that work is actually a level 9 CE within the civil engineering space. So not everyone is a 9 CE. Our small players are actually within the level 3, 4, 5, and then we do get some work in the level 7. So with that in mind, you still get inexperience when it comes to certain disciplines within the construction contract. Then that's where our subcontracting comes into play, because for 10 key projects, for example, a construction company might not be designing pipes, but they might still need to get a designing company firm or a designer to design and then sign off the designs. Similarly to cathodic protection and other disciplines within construction, we do need to bring the right people to do the work. Because then if you inexperienced and you're a new 9 CE, and Nthabiseng at Rand Water is assuming that you actually are experienced as Rand Water, I think our minds have been open to the fact that not everyone is a specialist in everything. And it's also good to have new contractors coming into the economic space in the country. So for the specialized work, we do recommend work that must be done and companies that must undertake the work for the contractor.
Well, that's good to hear. And I'm hoping that some of these new, less experienced contractors are gaining the necessary experience so that we build up a new repository of experience and knowledge and understanding in a greater space within our country. And I guess to some extent, that's sort of what we're hoping to achieve through this platform with Bite-Sized Corrosion and Isifundi training, is exactly that, is to try and share the knowledge so that we don't all burn the same pie every time we try and bake it.
They definitely are gaining the experience, because
That's wonderful.
just for construction or chambers, for example, there is work that comes out within the tender space for, a meter connection, and it's just one chamber, and the work is within the 2 million threshold. So that allows for a person of a 3 CE level of CIDB grading to conduct the work. So it's not always the experienced contractor doing the work, and at the same time, the small player is also gaining knowledge and experience within the Rand Water space.
That's wonderful to hear, and really encouraging that we are getting broad development economically. That's wonderful. And Nthabiseng, a question that actually came to us, we were talking about the outages, those planned Rand Water outages that were held a few months ago. And I'm very well aware that you as Rand Water have implemented these for precisely as you've been speaking, tying in supplementary or augmenting or a new pipeline joining to an existing one. And those are all kind of either maintenance or mechanical reasons. And I just wondered whether they used those opportunities when we were out of water for a couple of days. Were they doing corrosion protection as well at the same time if there was corrosion protection required?
Yes, it's definitely part of the plans with every shutdown that occurs. Basically, we have our own construction crew, at Rand Water, believe it or not. So there are tie-ins that are made through the contractor because we're completing the project or we commissioning or we want to pressure test. And then there are outages that are done by Rand Water through the Rand Water construction crew. And then that would involve, Nthabiseng fabricating the pipe fittings. That would involve Bagcinele from pipeline protection and Tabang coming into the space and actually planning around the shutdown on their involvement on how to protect the safety of personnel and the welders touching the steel line with overhead power lines being sometimes part of the environment, and then also cross bonding or doing whatever necessary in order to ensure electrical continuity of the line that we're joining. So there are interventions that are being put in place with every shutdown that we have. And then just to also go back a little bit, not just on the outages, but on new constructions. So the cathodic protection part of the scope of work for cathodic protection actually becomes a part of the contract, with the CP team actually monitoring the work. We call them Rand Water representatives, monitoring the work and ensuring that at the end we don't have coating defects. Then they run, DCVG surveys at the end. They do current drainage tests at the end. And whilst construction is happening, then there's installation of, our sacrificial anodes, not just for when we don't have the ICCP system in line yet, but also for cases of vandalism. When we don't have it, then we still have sacrificial anodes. We still have them in order to assist us with protection of the line.
And Nthabiseng, thank you. Thank you so much for sharing with us what's really quite encouraging news to hear that our water utilities are making the most of the opportunities. They are considering the ramifications of the environment as well as the water in the space in which you're dealing. So it's been really valuable to me, and I hope to our audience, to get these insights and that we all leave today with some more knowledge. So I do thank you for that. Take care.